Hello and welcome to the 2024 Meet the Innovators TCT Women in 3D Printing Innovator Award panel session. My name's Laura Griffiths, I'm the Head of Content at the TCT Group, and I'm very happy to be joined by Kristin Mulherin, the President of Women in 3D Printing and Director of Additive Manufacturing Technology at Hubble. Great to have you here with us, Kristin. So today we're going to be revealing the 5 finalists for this year's TCT Women in 3D Printing Innovator Award and getting to know each of them, their journeys into additive manufacturing and contributions to the AM industry. Before we do though, I just want to give a bit of a brief introduction to the award itself and the TCT Awards overall. So TCT and Women in 3D Printing got together in 2019 in a collaboration to launch this TCT Women in 3D Printing Innovator Award. TCT has been a leading source of intelligence for 3D printing, additive manufacturing for over 30 years, and through our international portfolio of magazines and events. One of those events is the annual TCT Awards ceremony, which is the industry's biggest celebration of AM technologies, applications, and collaborations. So in 2019, we partnered together to launch this award to recognise the women who are leading the charge in developing, enhancing, and innovating within the 3D printing and AM world. Since we launched, we've handed out 3 awards to Professor Y.E. Young, Eliana Fu, and Dr. Alba Gonzalez Alvarez. So this year's finalists and eventual winner are in very, very good company. So we always start with a public nomination process in which we're typically inundated with hundreds of deserving winners. And then TCT and Women in 3D Printing have the very difficult task of narrowing that down to our list of finalists. After today's panel session, we'll be putting that responsibility back onto you, the public, to vote for this year's winner. So before we meet our finalists, Kristin, could you just tell us a little bit more about Women in 3D Printing, where the organisation came from and its ambitions?
Sure. Thanks, Laura. So just a bit of background. Women in 3D Printing was originally founded with a mission to close the gender gap in the additive manufacturing industry. But as we grew, we realized that our mission should be bigger and quite honestly more representative of the over 20,000 men and women that we participate in our events and initiatives globally. Specifically, our mission is to create an industry that's more representative of the world we live in, an industry more inclusive of the diverse cultures and backgrounds we see in our daily lives, whether it be race, religion, LGBTQ identification, and others. It comes from a belief that all industries could greatly benefit from being representative of a true cross-section of society. But specifically, in an industry such as ours that is so fast-paced, innovation is critical, and I sincerely believe that innovation is best driven by the most diverse teams. With that said, our community is primarily involved in the industrial side of 3D printing across aerospace, healthcare, automotive, and other industrial sectors. Starting with just 2 chapters in Paris and San Francisco back in 2014, we now have over 100 chapters worldwide in 40 countries on 6 continents. We are an all-volunteer organization. So to help with the day-to-day, we now have regional directors in our 5 primary regions: North America, Latin America, Europe, Middle East and Africa, and Asia Pacific. And we have over 20 area managers to manage the sub-regions, such as East Africa, China, California, Southeast US, and Canada, to name a few. So what do? We have 4 primary areas of focus, some very well developed and some just beginning. First is our local chapters. Our local chapters are exactly what they sound like. They host local gatherings. Each chapter holds multiple events per year, which can be simple happy hours or lunch and learns, or expert panels, tours of local companies, or virtual gatherings. I highly recommend going on the Women in 3D Printing website to find your local chapter. All are welcome, and our events are usually free to attend. We want to ensure we can reach the broadest audience possible and to be inclusive to all. Second is our DEI program. We'll be rekindling our DEI program later this year with more news to come. Third is our NextGen program. Our NextGen program has a mission to increase awareness of career opportunities in AM and to create networking opportunities between students, recent grads, and professionals. The next iteration of our mentorship program will be announced later this year. And then fourth is our TYPE conference. We've held our TYPE conference for the last 3 years with over 2,500 virtual attendees at each of them. TYPE stands for TIPE, Technology, Industry, People, and Economics. We wanted a more people-centered focus at our events, so that's why we've included the people and economics tracks. But this year, we went on hiatus to focus on something special, our first ever in-person global gathering. It's going to be quite different than what many have become used to at our local or regular TYPE conferences, but we're very excited about it, and there'll be more news to come later this year. In the meantime, we're going to be holding TYPE panels at some of the major upcoming events. These will integrate the 4 tracks that have become synonymous with TYPE, with one panelist representing each letter, but focusing on the same topic overall. They should be quite unique. So with that said, I'll hand it back to Laura to introduce our nominees for the TCT Women in 3D Printing Innovator Award for 2024. We have a phenomenal group of women this year.
Thanks so much, Kristin. And as you say, there's so much to get involved with this year in Women in 3D Printing. You can go to women3dprinting.com to find out more about all the events and gatherings that are happening throughout 2024. So I'm really excited now to have the opportunity to announce this year's finalists. Are we ready? So the 2024 TCT Women in 3D Printing Innovator Award finalists are: we have Brigitte de Wetwethen, CEO of Materialise; Cora Liebig, founder and CEO of Chromatic 3D Materials; Melissa Orme, Vice President of Boeing Additive Manufacturing; Olga Ivanova, Director of Technology at McNano; and Nesma Abulka, Director of Additive Manufacturing at the Technology Innovation Institute. So let's bring them all onto the virtual stage. Hi, everyone.
Hi.
Very excited to have you all here. I know we've got lots of different time zones and various busy schedules to contend with today, so I really appreciate you all taking the time out to meet with us all. This is really going to be a get to know you session for all of our finalists. I really want to just use this 45 minutes to talk about your journeys into additive manufacturing and the work that you're doing today as well. So I want to kick things off by starting with a question that I ask a lot of our Additive Insight podcast guests, and that is really about your light bulb moment with additive manufacturing. What was the moment that really got you involved in the industry, whether that was the first bit of 3D printing you ever saw or the first time the technology really clicked with you? And I think we'll go in alphabetical order by first name. So Brigitte, I'm sorry, that means you. If we could, what was your light bulb moment into additive manufacturing?
Yes, thanks, Laura, and thank you for having us today. Really pleased to be in such a talented group of people here. So yes, my light bulb moment was really when I heard about a patient that was treated with a patient-specific implant. This was a patient that had been in a wheelchair for more than 3 years. After multiple operations on his hip, always failing after some time. And at one point in time, there was just not enough bone left in the hip to put an implant in a way that the patient still could walk. So the patient found themselves in that wheelchair until he found a doctor that essentially said, we can help you with a patient-specific implant. Mm-hmm. That patient-specific implant was indeed made by Materialise, placed in a long operation. But the amazing thing is that 6 weeks after the operation, the patient could walk again. You can imagine how life-changing that is for the patient and the whole environment, families, friends, etc. So that really was the moment where I thought, wow, additive manufacturing is here to stay and is here to have a huge impact, for example, on these patients, but also in many different other applications.
Well, that's such an amazing intro to the technology there. Cora, we'll go to you next. What was your kind of entry point into additive manufacturing?
Sure. So just a little context. I had spent 20 years in the materials industry, and being in the materials industry, I had a lot of had a lot of experiences with supply chain and supply chain complexity, and found that supply chain complexity was getting in the way of innovation and in materials and sustainability, et cetera, and a lot of things that all of us as a globe want to see happen. And my kids do speech and debate, and I was a judge in a speech and debate tournament, and a high school student gave a wonderful presentation about 3D printing and what was possible with 3D printing. And I remember over the course of his talk, it was a 10-minute speech, my mind was just ablaze with, wow, this could just really transform how materials are made and what kind of innovation could be possible with it. And from there, that was definitely the light bulb moment. I think I scribbled a business plan on the score sheet or something like that. And I was fortunate that Stratasys is right here in Minneapolis, where I live. I was able to do some tours and start to understand a little bit more about the industry, what needed to change, what needed to be improved to have an impact. But it was definitely a speech and debate tournament. So you never know.
Wow, That's incredible to know that it came from something like that. And wow, I to think maybe that young person might end up with a role in this industry at some point. Melissa, what about you? What was your entry point into additive manufacturing, or the first time you remember seeing the technology?
Okay, so for me, it was a long time ago. I was a graduate student working on, finishing up a PhD, and I was working on electrostatically charging and deflecting droplets in a vacuum chamber for a space application. And it was 1989. Chuck Hull was just introduced stereolithography. I went to Valencia, which is, not too far from where I was at USC, and visited. And it was so cool. And I thought to myself, what would happen if instead of like oil droplets in a vacuum, I was going to jet molten metal droplets onto a target? Because I found ways that I could, manipulate them and control them within microradians, because I was going really far and at a very high rate, not inkjet printing. It's a different technology where it's about, an order of magnitude faster. So, I finished my PhD and I got a position as a research assistant professor at USC. This was before I got my tenure track position at UCI. And I wrote a grant and I created an apparatus and I started jetting solder. And then I moved on to aluminum and I started creating, what we call net form parts. So it was really just the convergence of, stereolithography, which is very different, and me finishing up my PhD thesis on something that I thought, hey, I think I can convert this into this new technology. Mm-hmm. And I later got a position, a tenured position at UCI, and was working on it ever since. So I have been, in additive manufacturing since, very, very, very early days. And at the university, I was, working on aspects that were, basic science, fluid mechanics, heat transfer, phase change, how the impacts, the material science aspects of the net form and things like that. So anyway, that was my light bulb moment. Was probably, just the press around stereolithography coming into play and me figuring out how I could do something.
It's so interesting to hear that background, and I'm very excited to later on in this conversation ask you a little bit about that, those earlier days of the technology. Nesma, what about you? What was your intro into the technology?
So my background is mechanical engineering. So I've always worked with materials and manufacturing throughout my studies, mainly undergrad and masters. But I did all that in Egypt, so I didn't know anything about 3D printing. It didn't arrive there 12 years ago. People didn't know about it. So I went to the UK and I was doing a PhD on composite materials. In my first year, I just found a seminar about additive manufacturing and 3D printing, and I didn't know what that is. I went to attend out of curiosity, and then they were talking about 3D printing of aluminium, which impressed me, how you can just 3D print, because it's something very new for me. So it impressed me, the challenges that they were talking about. I've always been interested in how things are made, the marriage between materials and manufacturing. My dad is a mechanical engineer, so that's also inspired me to work in that field. And I saw 3D printing has a huge potential to solve a lot of the problems that we have in supply chain and in conventional manufacturing and limitations. So that's why I thought, I'll take the risk. And I lost the first year of my PhD funding working in composites. No offense to composites. I still was the best decision I made so far. And I've been working in metal 3D printing ever since. Shifted my PhD to 3D printing aluminium to try and solve some of those problems they were talking about. I think I successfully did. And then I got a fellowship. I started looking into drop-on-demand 3D printing of metals as well. And I've been working in AM since.
Wow, so proof that it is good to take risks sometimes, especially in this industry. And Olga, finally, what about you? What was your entry point into additive manufacturing?
Have you ever had a light bulb moment where something just instantly clicked? So just brace yourselves. That's exactly what happened to me, and I will take you to the beginning, how it happened. I'll be very short. I did the math, how much time we have here. I've got PhD in chemistry, specializing in nanomaterials. And I always thought about your postdoctoral training as an opportunity to step out of your comfort zone and dive into a new technology. So I stumbled upon job opening at Virginia Tech that revolved around nanocomposites for 3D printing. Notice I'm talking about 3D printing. Additive manufacturing wasn't even a term back then. So, sure, I knew nano, and I had zero knowledge about 3D printing. However, I saw the technology for the first time and fell head over heels in love with it instantly. The kind of love that sneaks up on you and suddenly consumes all your thoughts. The possibilities seemed limitless, and just I couldn't help but admire the innovation behind the technology, how it seamlessly merges creativity and efficiency, sustainability in terms of materials. I didn't let the fact that I know nothing about the technology stop me. So I grabbed the opportunity. And fast forward to today, it's been 14 years I'm in the field and had worked on a ton of amazing projects, mainly focusing on developing new materials for various applications, whether it's be 3D printing of textiles or medical devices for prematurely born babies, even pyrotechnic flares. Things got a bit explosive during that one. We're not going to go into details of the project here. Also had a blast developing applications for metal laser powder bed fusion systems while atop an additive. And really, the whole experience you, Laura, mentioned, like, it was leaping into unknown and ending up discovering so much awesomeness you never knew existed. And it's like life has the ways of leading you down an unexpected path. And today I wouldn't change anything. I'm having too much fun.
Olga, I love that. You can always rely on you for a good passionate speech about additive manufacturing. So, Kristin, I do want to put you on the spot, actually, if that's okay, because you've got an extensive background in metallurgy and then working for various different organizations in additive manufacturing. What was your entry point into the industry?
Oh gosh, yeah, mine's not nearly as interesting as the ones I just heard. So I'm hesitant to even touch on the topic. And this is like, your guys' stories are so fascinating to me; it blows my mind. I think it wasn't really the light bulb moment for me, but the one that was really interesting was, coming full circle. I was at UCLA considering doing a PhD in biomedical engineering, and I was a material science at the time, and I was tapped for this particular project because they wanted me to develop the scaffold for implanting stem cells. Now, it was really interesting because it was not using 3D printing. And so what happened is then many years later, I go and I enter the 3D printing space. And I realized, I was like, oh my gosh, those scaffolds, they should have been 3D printed. And I still think about it to this day about what happened with that project, because it was such a great project for 3D printing, but for some reason they hadn't thought of it. And it makes me, every time I think about it on a regular basis, about how I really want to go back and tell those people, and find out what happened and say, you should have been using 3D printing for this project. So it was not a light bulb moment as much as just kind of a full circle moment. Okay.
And I'm sorry to put you on the spot there. So I've got some individual questions for everybody now, and then we'll wrap things up with some more kind of general discussion points. But I want to ask each of you a question just so we can kind of get a bit more info on what you're actually up to in the industry right now. So again, Brigitte in alphabetical order, I'm going to start with you. So you recently took over as CEO of one of the oldest and largest companies in additive manufacturing. I'm really interested to know, you've been at Materialise for some time now, but what's motivating you right now about being at the helm of a 3D company at this particular moment in time?
Yeah, I think it's a perfect moment to be at the helm of Materialise, because I think in the industry at this point in time, we're going through a couple of really important changes. And they're exciting. I think, as we all know, the additive industry has taken some time to find its place and is still taking time to find its place. And the way I look at it is that we're really in the middle of that shift from the use of additive manufacturing for prototyping, where it's very well established. We know it's the solution to do that. The shift is happening towards the use of additive manufacturing in production of end-use parts. And that is where, you know, there's huge potential. And we're in the middle of that shift. And if you think about that shift, if we start to use additive manufacturing in the production for end-use parts, the needs of people to effectively and efficiently do that are very different from using additive manufacturing for prototyping. And it's really exciting to be at the helm of Materialise in that time where we see new user needs and where we actually can drive with technology, we can drive the adoption in that end-use parts segment. Just because of, you know, we understand the future needs of the customers, and we use technology to drive further adoption in that. So it's a really exciting time to be at the helm of a company to drive that shift and take part in that shift. And that in particular, because of the second shift happening, which is that, you know, if you look at the world from a broader perspective, a bit more of a helicopter perspective, sustainability has become a much more important topic. And we need to make sure that, you know, our planet is sustainable and will be there for, you know, our children and grandchildren. And we all know that additive manufacturing can play a super important role in reducing the footprint, the CO2 footprint, in many different ways. So contributing to that shift, being at the helm of Materialise with the solutions that we offer and the drive of the use of the adoption of use of additive makes it particularly important and exciting at this point in time. So that's why I think it's a perfect time to be at the helm.
Great, and I saw so many good examples of that back in Frankfurt in November, of those end-use applications and some part volumes that you almost can't believe that we're already into those kinds of volumes with metal additive manufacturing in particular. So like I say, it's really great to see that already happening now.
Yes, absolutely. Yeah, it's happening as we speak, and there is so much more potential. But you know, it is happening, definitely.
Mm-hmm. So Cora, I'm going to move on to you now. I know Chromatic recently worked on a collaborative 3D printed dress project that responds to its environment through nearly 75 LEDs. It's very cool, and if you've seen it in person, like it's kind of amazing just to watch it all happen, and it's all very much lights up the room. Chromatic was founded in 2016 to really expand the range of materials that are available for polymer 3D printing and really push its applications through that. Can you elaborate a little more on the material developments that have made this latest project possible?
Sure. So what we did at Chromatic was take an established, 3D printing technology like FDM with extrusion, and instead of having a melting process, we have a reactive process. So by doing that, our goal is really to make it possible to print with the materials that are just really trusted in industry, namely thermosets and other very durable materials. And so what was made possible for the dress was that in essence, we're printing with the glue. And so what we were able to do, and what we've done is made that glue just also stand up and hold structure. So what we were able to do for that dress was print directly on the textile, something that would adhere to the textile. And because it's not a high temperature environment or anything like that when we print, it's we can essentially use whatever, we can do that printing process in a temperature that works for the material. And then the other important thing that needed to happen was that we needed to develop the printing technology itself. So that, printing that on the dress required printing essentially 90-degree overhangs with no support structures. And that's all from, really developing that chemistry and the printing techniques to make that possible. Mm-hmm. And we were also able to encapsulate LEDs, et cetera. And the collaboration with the Nuke was just wonderful. So really it was, we chose the dress as a great way to demonstrate just the versatility of the printing process for applications well beyond apparel.
Mm-hmm. And I think that's the great thing about it. As I say, it was quite a showstopper when I saw it, and it's a good way of having these developments, but showing it in a really accessible way, and something that industry can then learn from too. So Melissa, going to move on to you now. And you talked earlier about your early entry into additive manufacturing, and you've shared your years of experience on many TCT stages up to this point. But during the nomination process, you were described as someone who belongs to that small group of engineers who have participated hands-on in the field of AM before the term and the AM industry was even developed. So as a leader now at one of AM's what I call super users, how has that early hands-on experience shaped the way you view additive application opportunities today?
I think that, all of my experiences that range from academia, doing basic research in additive manufacturing, to working in a small startup service bureau, understanding the pains of, survival there, and then to leading, a large corporate group, actually inserting additively manufactured components onto, airplanes and drones and helicopters and satellites. I think having all of those experiences helps me really, one, understand the culture of each environment, and which is really is important when you're leading this group. But also it helps me understand what's really possible, right? What is the art of the possible? What should we push for? And what can the team actually achieve now? So I feel like I'm an more effective leader by understanding the technology, understanding what really can happen, knowing that I'm not asking my team the impossible, knowing how to give them big stretch goals, because, that creativity from the hands-on work, that's still in me. And I'm still trying to do that through the team, right? So I think mostly all that different experience from academia, small business, tech startup, and executive leadership. It's just it helps to find the culture. It helps me understand the culture of each particular group, and helps me lead better, essentially.
Mm-hmm. Yeah, so many different threads to pull on there, as you say, from academia to industry. It all really, it's so important that those things kind of know how to fit together as well in order to make it a really viable technology.
Yeah, if I can just add, there's, I've seen, like, from the academic point of view, a lot of, people in academia, they have certain ideas of what can happen. And then from an industrial point of view, there's completely different ideas of what can happen in terms of sharing data and things like that. And I happen to, have good experience in each. I feel like I can bridge those, which I think is really important. I think I'm pretty passionate about the fact that I think if you're leading additive manufacturing, you really need to understand it. You need to have experience in it. You can't just be a manager that comes in, and so that's something that's important to me.
Mm-hmm. So Nesma, I actually remember seeing you very briefly back in my early days at TCT. I think it was at the lab at Nottingham University as part of a conference tour I was on. So you've got also this huge background in additive manufacturing, metal additive manufacturing in particular. But over the last 3 years, you've been at the helm of AM implementation at the Technology Innovation Institute in Abu Dhabi. So the Institute focuses on numerous technologies, I understand, so not just additive manufacturing. So I'm wondering, how significant is AM there, and what kind of impact is it having?
So the Technology Innovation Institute is an applied research R&D company, So it's not just additive. Actually, additive is one division within one of the 10 research centers in the company. We work together in emerging technologies, state of the art. So we cover AI, directed energy, autonomous robotics, advanced materials, and so on. But I'm responsible mainly for the additive manufacturing. And the move here was basically to start an additive manufacturing group that can put the strategy for the UAE government on how can they start exploring additive manufacturing, because the landscape here is very much behind what I was doing in Nottingham and what I've seen in the UK and what you see in the West in general. So it was basically starting from scratch. We had a blank slate, and I was just starting with that. And I'm glad that over the past 3 years now, the AM division has 4 verticals. So we work across the workflow of metal additive manufacturing. I have a fantastic team working on the 4 verticals of materials. So we're developing new materials specifically for metal additive manufacturing, which is one of the amazing capabilities of the technology. It's not just to manufacture, but actually you can create new materials, new microstructures from scratch while manufacturing.
Mm-hmm.
So we're capitalizing on that, and we've recently just filed patents for 2 new alloys that are the first materials that come not only from the UAE, but they come from the MENA region in general. So that's quite an impact that we've created in just 3 years, starting labs from scratch and doing that. We're also working on processes, we're working on design, and then the applications that put all these together and trying to solve the problems of the industrial landscape. So this ties in really nicely with what the UAE government is pushing for, trying to transition from an oil and commodities-based economy to the knowledge-based economy. And I think we're playing a very critical role there. The country has lots of nice initiatives that push for manufacturing, such as Make It in the Emirates, and we are here to support them in this initiatives and trying to attract investors to come and manufacture in the UAE.
So it's very much a watch this space sort of thing, but it must be so exciting to have gone into a new place and just have the opportunity to start things from scratch and get to pick and choose the things that you thought were going to be significant and important to focus on.
Exactly. Yeah, it's been an amazing journey so far.
Mm-hmm. And so, Olga, on to you. You recently guested on our TCT Additive Insight podcast, and I was saying earlier that I can always rely on you for some good additive enthusiasm, but you also suggested that AM still really needs to cut the hype. Why do you think that this continues to be a challenge in the AM space, and how does that impact the work that you're doing as a developer of new materials technologies?
The reason I'm laughing right now because I will never leave that one down for sure. It's the ever-elusive hype machine in additive manufacturing. I recently read somewhere that additive manufacturing has gone from hot topic to hot mess.
Wow.
And let me be clear before I crush everybody's hopes and dreams right now. I think AM has endless possibilities, and the allure of the technology is undeniable. However, here crushing the hopes coming, the inherent novelty of additive manufacturing sparked the exaggerated claims and inflated expectation. And it's not just additive, it's any new technology going through that cycle, any scientific breakthrough. Just remember, we're supposed to have elevator to space built based on carbon nanotubes. Where is that, right? People will become captivated by this shiny and new. We love revolutionary breakthroughs, promises to disrupt industries. And this creates this contagious frenzy driven by a desire for a quick fix-all solution. Like, who wasn't excited reading about printing bionic limbs and entire houses back in the day? It sparks imagination. And we humans tend to get carried away with our expectations and tend to imagine possibilities beyond what's feasible. Don't forget about power of marketing. Companies will tap into hype, promising manufacturing transformation. Media, sorry, Laura, sensationalizes every development, oftentimes blowing it out of proportion. And the words like groundbreaking, cutting edge, they're thrown around like a confetti at the wedding. So the hype machine keeps going for years. And it's fueled by possibilities and novelty and media media.
We're sorry.
And frankly, no, I'm referring more to articles like Economist back in 2010 or 11, Print Minister Divaris. Like it's those kind of pieces that, fueling the hype. And frankly, it's also fueled by our own desire to be part of something groundbreaking. I remember first time when I started 14 years ago, I felt like I'm in the front row at a rock show. You're just having so much fun and you imagining all these possibilities and you're building all this cool stuff until reality hits in. And I don't think as a technology developers, dealing with the hype. What we're dealing with right now today is the aftermath of this peak hype period in additive manufacturing history. And what I encounter is 3 distinct customer types. First, let's call them the eternal AM optimists. They believe AM holds a key to solve every single one of their problems. Yes, those customers still exist. And with them, we have to burst that bubble and bring them to reality and show them the limitation, yet at the same time, keeping the enthusiasm alive.
Mm-hmm.
The second group that I encounter a lot, what should I call them? It's been that, done that, didn't work gang. They tried and failed, had their dreams shattered, and now they're too terrified to give it another shot. It's compared to getting out of the failed marriage, and you don't want to commit to any relationship because of the pain you experienced in the previous one. So with these customers, you have to lure them out of all their fears and build the trust and confidence. And it's not trust and confidence in me when I'm talking to them or our company. It's a technology as a whole. So we as a community have work to do.
Mm-hmm.
And the best customer, sorry to the other customers, but the best one is like all of you on this panel, is the enlightened ones who actually bought in the hype, endured the painful implementation processes and learned their lessons, and a lot of times hard way. And now they understand that additive manufacturing is just a tool in a vast manufacturing toolbox. And as Melissa mentioned, and I will paraphrase because I don't remember how you exactly said it, it's those type of customers, they understand that the usage of AM should be strategic and when it makes sense.
Mm-hmm.
Those are the easiest to talk to because they've been there, they've done that, and they know what they're getting themselves into.
Mm-hmm.
That's it. I'm done. That's my spiel about the hype. I hope you're still hopeful and enthusiastic about working in additive manufacturing field.
Well, after that uplifting speech, I'm going to give everybody else a chance to crush dreams now, because I think it is important that we do highlight this stuff. You know, everyone is active in the industry now, has been through the ups and downs of the technology and the kind of promises that we've seen. So I wonder, for everybody else, is there a piece of hype or some additive assumption that we continue to perpetuate in this industry that you all wish you could just do away with right now? I throw that out to anybody. I won't put it on Brigitte first again.
I think Melissa wants to go, if I understand your hand correctly. Go
ahead, Melissa.
Thank you, Brigitte. And Olga, I agree with so many things of what you said. You know, at Boeing, we're in a different space than many people here on the call and many of the users because we have a very specific application, right? We're looking at parts that we can create value to the end product. We're not printing parts for the sake of printing parts. And you know, one of the biggest pieces of hype is that, you know, you can use additive for everything. Well, the question is, should you? Right? Because, you know, I always want to say, like, I mean, should you print that part when you can machine it so much easier and faster and cheaper, right? And so you really have to find the business case where you're, in our case, we're adding value to an entire platform. We're increasing its performance, we're increasing its range, we're making it cheaper, we're making it more sustainably. But the big amount of hype that bothers me in my industry specifically is that you can, and this is for lay people or people who are just getting into additive manufacturing, you know, people who understand, you know, are going to understand. But I still have to explain to people that for making spare parts on airplanes, you need to have engineering rigor, requirements, testing. You can't just print a part out on the field somewhere and put it on a helicopter and expect it to fly. And you know, there are requirements that must be met, and those, you know, it takes certain engineering analysis, it takes testing. Those requirements can be reduced if it's not holding people, if it's on the ground, if it has wheels instead of wings, right? But for airplanes, the biggest amount of hype that really bothers me is that you can reduce requirements on spare parts. And, you know, that's particular to my business. And, you know, really what has been underestimated is the amount, what's required for implementation, you know, the amount of data you need to have to qualify a material source, to understand the material system, to, you know, create design allowables, to understand the damage and durability, to, you know, just to understand the material aspects of it. And that goes for all parts. So yeah, the hype of just quick fix for airplanes, I would like that to go away.
It's in the bin.
We have to do it right. And we can be pretty quick, but we have to do it right and responsibly, basically.
Yeah, I would want to give a slightly different perspective on it, because I echo very much what Olga was saying. I echo very much, Melissa, what you were saying. It really is about those applications where additive manufacturing can add value, and there's a lot of people that don't understand that yet. It's not about the technology as such, is what you can do with it in the right places. Now, the hype that I would want to take away is a bit the effect that all of this has had, and that's actually the opposite of a hype. Because when you look at, you know, how investors, for example, are looking at the additive manufacturing industry, there's a belief that this additive manufacturing industry is never going to take off. And that is actually also not true. There is a huge potential still in additive, but it is going to take time. As we all know, it's hard work. It takes time, and it's, you know, we need to take this step by step. It's a slow revolution. It is a revolution, but it's a slow revolution. And what I wish we could take away is that negativity that is there, you know, in a lot of camps. Investors are just one example. And that we could take that negativity around the sector away, because that is really going to be creating plenty of problems. For example, for startups and smaller companies who at this point in time don't get funding for great technology that holds potential, but just because there is this negativity. So it's not a hype that I want to take away. It's the opposite of a hype. But I think it's equally important to take that away.
And I would just add that, you know, we all described at the beginning our light bulb moment, and it was an insight that this would be transformational to health, to manufacturing, et cetera. Today, 3D printing is less than 0.1% of all manufacturing. You can't change a multi-trillion-dollar industry without, you know, overnight. And I do believe that 3D printing needs to find its place. It's not going to replace all manufacturing processes, but I do believe it's going to go somewhere from 0.1% of manufacturing to more like a few percent, or 4 or 5%. So there's a lot of growth that can still happen, that will still happen. And we're not done developing the technology and the applications yet. And I think that's that. And so I think all the hype that happened about, hey, here's how 3D printing will change how we do things, is right. I don't think it was wrong. I think it's simply that it takes time to get there. And we're all doing that work. And that's why I'm so excited to be on this panel. But and just to build off of what Birgit was saying, I think that one of the myths going on right now is that consolidation is necessary in the market in 3D printing. I'm not sure consolidation really is what's needed. Consolidation might be what happens for economic reasons, but I really believe that startup community is, you know, that I'm a part of it, is necessary to continue to develop the technologies that are going to move us forward. And that proliferation of technology, that continued improvement of technology, is absolutely essential for 3D printing to achieve what it's destined to achieve.
And Nesma or Kristin, anything else to add on that side of any myths or misconceptions you want to get rid of?
I think just to dovetail on what Cora was saying is, it is that fear that people have. There's two sides of it. That fear people have of that are in traditional manufacturing, that we're here to like obliterate their careers. We're gonna overtake all traditional manufacturing. As Cora said, I think it's realistically going to be a few percent. I think 5% is probably even ambitious. And I think getting rid of that fear is really important. And then I think on the opposite side of the same topic is the expectation that we're going to be able to take over all of traditional manufacturing. Again, back to what Melissa said earlier, it has its place in very specific applications, very specific value drivers. And I think you can see both sides of it, the expectation and the fear of us replacing traditional manufacturing as a whole. I think that is a something, the hype that I'd like to make sure that people understand. And it all boils down to just education. Mm-hmm. And just educating people on where and when it makes sense to be using these technologies.
And Nesma, I'll throw it to you.
Everything that has been said basically covered all the things that we want to get rid of. Just to add to that, it's the misunderstanding of people who want to use additive, that it's just a plug and play. Let's buy a printer and let's replace conventional manufacturing, no matter what material, no matter what AM technique that you're using. And they don't really see or appreciate the amount of research that goes in the background just to qualify one material or to print one part, or actually assess whether it's feasible for 3D printing or not. So yeah, it's just this lack of awareness, if I may say, on the side of the end user.
Mm-hmm. And so unless Olga needs to add any more misconceptions that you would also like to throw in the bin, you do.
Push and play was really good, or plug and play. That was mine. You took it away from me. But the other one is...
Sorry.
No, you're good. I'm just kidding. Every household a factory.
Yeah.
That's what we kept saying, that we're going to build replacement parts for our, at least, kitchenware or whatever, washer and dryers at home. And it's so easy, and average Joe can do it. And again, as Kristin said, it all comes down to educating people. A lot of people just don't bother really to learn what it takes to even build a part. It's part orientation, it's support, it's removal, it's post-processing if you need to. It's so much more than just hit play, download model, hit play, and next morning you come and it's ready to use. It's I don't have printer at home. I'm probably the only one who doesn't. I don't want to. It's cheaper to go to local store and Ace Hardware and buy whatever you need. I don't want to build fittings. I can get them for $5 for 100 of them. Why would I?
I think that's a nice reality check to nearly close on. I know we've only got about 5 minutes left together, so I just want to ask you all to finish off the session. Cora, I'm going to borrow something that you said in a blog post actually that I read last year, and you said that you saw 2023 as, quote, the year to get practical about additive manufacturing. And I think that's really nice, because I think that's kind of what we talked about today, the realities of additive manufacturing, the practicalities of it. I'd like to know from each of you, what do you think 2024 is going to be the year of for additive manufacturing?
Do you want us
to go by alphabetical order? I'll start.
Let's go alphabetical. I feel like it was working for us in alphabetical order.
Yes,
okay.
Absolutely. So there's one thing that is going to be the reality, and there's another thing that I would hope that would happen. So I think the reality is probably going to be, sadly, that 2024 is the year of the shakeout of the industry, because of that negativity from an investor side and from a financial side that is around. I think it's going to be a difficult year for many companies, unfortunately, and that will mean that we'll see shakeout is a dramatic word, but I think we'll see change in many places. What I would hope it is that it's a year where we have more women in 3D printing, certainly also in leadership positions. Because I do think, not because of the women, but because of the balanced gender, being the right way of driving the right decisions, driving the right things forward. And that's what this industry needs. We still have progress to make. And I think a balanced slot with men and women and other diversity factors around the table is what is needed to make that happen. So that's what I would hope it's going to be.
And Cora, what about you?
it's building off of the year to get practical. I'd say it's the year to get profits. So it's really a time when business execution and kind of the teams that are able to navigate how to take the technology and really make money from it are the ones that will see the most success.
Okay. Kristin?
Oh gosh, I think there's a lot of things, but I think, I'm now on the end use side of things. And so I'm seeing it from a very different perspective than I have for the majority of my career, and it's about driving towards those new applications. I think medical, automotive, aerospace, they're on a very steady track right now. I think they've identified a lot of strong business cases, those killer apps that can help drive AM. But I think it's time for some new industries to start to really emerge with some really interesting applications from the, I'm on the electrical services side of things, or electrical solutions side of things. And there's a surprising amount of things that we are producing that you've never heard of. Same thing, done all the major industrial sectors, automation, robotics, and all of that. So I think we're going to start to see a lot more new applications emerging.
Okay. And Melissa?
I will dovetail off of what Cora said, and basically, at Boeing, we have last year already shown that we're making a profit, right? We have 2 order of magnitude ROI, return on investment. So I feel like, at least for Boeing and aerospace and defense and other industries too, we've matured. And in terms of the industry, the machines, they've had their years of, getting bigger, better, faster, more lasers. I think we're kind of done with all these incremental changes, and they're not as significant. I think this is actually going to be the year of data, and where data is very important. And that's kind of where we are at Boeing. We've really, we've gone through the hype. We've found those killer applications. We're making money. And now in order to stabilize our process, in order to scale, we really realize that it's imperative that we integrate all of our data into the digital thread, that we contextualize it, we can make it accessible for our data scientists to make machine learning algorithms that can help with predictive quality. And this is exactly where we're going right now. And that's the only way, in my view, that we can industrialize additive and we can scale. And so, that's 2024, the year of data, in my view.
And Nazma, what about you?
So I echo what Melissa said, actually, that I think it's going to be the year for the merging between AI and additive manufacturing, AI and AM. But if I had to add something else, then I would say that I hope that it would be the year of getting closer to multi-material additive manufacturing, making some good progress there.
And Olga, to finish, what about you for 2024?
You know how hard it is to finish after all these amazing ideas and high expectations for 2024? Well, let's just say 6 days ago, six days ago on January 10th, New Year started according to Chinese calendar. And it's a year of the wood dragon. So I think we will experience both opportunities and challenges, as dragon represents change and adaptability. Let's hope change is going to be for the better in the additive community. And in a wood element, it typically means bringing growth and renewal. Let's hope our profits will grow, Cora. And our image will be renewed, Bridget, and we will get away from negativity, or at least dial it down a little bit from perspective of other people, so we can actually strive.
Great. Well, thank you. Sorry, go ahead.
That's it. Everybody's just so quiet. Shall I keep talking?
Well, we're actually over time now, so thank you so much. I really appreciate you all taking the time to meet today and to talk through all the various sort of insights you've got in the industry and your experience. As I said at the start, I know I've had a mix of time zones and different schedules to contend with, so it's been great to get us all in the one place. And that just leaves me to say now that the vote is officially open for this year's TCT Women 3D Printing Innovator Innovator Award. So you can head over to tctawards.com now to cast your vote, and the winner will be announced at the TCT Awards ceremony on June 5th here in the UK at the National Conference Centre in Birmingham. You can join us by getting your tickets at tctawards.com. So thank you once again to everybody, and thank you everybody who's tuned in today. That just leaves me to say good luck, everyone.
Thank you.
Thank you.
Thank you for having us.